Okay, today we're going on day 3, 7.3, properties of logs. We want to understand the change of base formula, the quotient, product, and power properties of logs. A lot of this stuff, again, we covered at the beginning of the year, so some of them I'm going to go through the properties kind of quickly. If you want some more practice on it, again, those videos are still available from the beginning of the year. So, first, change of base. Change of base formula allows us to change the base of any log into any other base we want. Now, most of the time this is really only used to change it into either the common log or the natural log, log base E. But we can change it into any other base, so it really doesn't matter. So if we want to change the following to common log and natural log, and I have log base 2/3 of x, well, to change it to common log, this would become log x over log 2/3. To change it to natural log of x over natural log of 2/3. Also, just to emphasize that you don't have to go from log base a of x to common log and then to natural log. All of these are equivalent. So I want you to pause the video, change log base y of 4.7 into the common log and the natural log. Unpause when you're ready to check. Alright, hopefully that didn't take too long. This becomes log 4.7 over log y, or natural log 4.7 over natural log y. Alright, so now I want you to use those skills and your calculator to evaluate log base 20 of 175, log base 4 of 0.045, and log base 1/8 of 64 to 3 decimal places. Pause the video, use your calculator, unpause when you're ready to check your work. Alright, so we know log base 20 of 175 is log of 175 over log 20, or natural log of 175 over natural log of 20. You do not need to write these down. I'm just showing you what they are equivalent to, and if I type this into my calculator correctly, I get 1.724. Just to practice typing that in if you're not comfortable with it or if you got something different. Natural log of 175, close parentheses, divided by natural log of 20. Hit enter. Or, like I said, you could do log 175, close parentheses, divided by log 20. Hit enter. Same thing. Okay. Log base 4.045 is negative 2.237. Log base 1/8 of 64. This we should actually be able to do without a calculator, but if you type it into your calculator, you're going to get negative 2. That should make sense because I know that 8 squared is 64, so 1/8 to the negative 2 is 64. Alright, so now more fun properties of logs. Again, these are the properties that we looked at the beginning of the year. So if I have log base a of x times y, I can separate this into log base a of x plus log base a of y. I can also go the opposite direction. If I have two logs that are being added together and they have the same base, I can combine them into a single log with multiplication. You can prove this to yourself by understanding the properties of exponents. This also applies to natural log as well. So natural log of xy is the natural log of x plus the natural log of y. That should make sense because, again, remember, natural log is log. It's just log base e. So if I make a into e, then I have natural log. The quotient property, log base a of x over y is log base a of x minus log base a of y. Again, we can prove this using properties of exponents, understanding that when we have division in the same base, we subtract the exponents. It's the same property going on here. And again, that applies to natural log as well. And log base a of x to the n is n times the log base a of x. So this is what we call our power property. Sorry, I was jumping the gun there a little bit. And you can also use natural log for this. Natural log of x to the n is x natural log. Whoops. Is n, I apologize, natural log of x. And you can prove this property to yourself as well. Okay, so first example, I want you to expand the expression using the properties of logs. So expand it, pause the video, unpause it when you're ready to check your work. Okay, so you could do this all in one step, but I'm showing you two steps just to make sure you understand where I get the answer from. So first, I recognize that here I have multiplication, and then obviously this is division. So I can separate this into three separate logs. Natural log of the square root of x plus the natural log of y to the fifth minus the natural log of z to the fifth. Now bring down each exponent. Remember, square root of x is the same as x to the 1/2. So I bring a 1/2 down in front, and I get 1/2 natural log of x plus 5 natural log of y minus 5 natural log of z. Next one, working in the opposite direction. I want you to condense this expression as much as possible. So pause the video, condense the expression, unpause when you're ready to check your work. Alright, so first I brought up the 3 on the x plus 2, and then I combined these two logs were addition, so I combined that using multiplication. This was subtraction, so I combined that with division. Now the 1/5 out in front, then last I brought that up as an exponent and turned it into a fifth root. So our final answer is log of the fifth root of the quantity x plus 2 cubed times the quantity x minus 5 over the quantity x squared minus 3. Don't multiply this out or simplify. I mean, if something is obvious that it's going to simplify or cancel, then do that, but otherwise just leave it like this. The point is to practice your properties of logs, not necessarily all of your algebraic techniques. Alright, so now we want to rewrite the expressions in terms of the natural log of 4 and the natural log of 5. So I'll do the first one with you. There's a few approaches you can take. So basically we're trying to think of how can we split up 500 into factors of 4 and 5. So for example, I know 20 times 25 is 500. So this is the natural log of 20 times 25. So I know that this becomes the natural log of 20 plus the natural log of 25. Okay, we're not done. Neither one of those are 4 or 5 yet. But 20 is 4 times 5. So this is the natural log of 4 times 5 plus, and 25 is 5 squared, or 5 times 5. Either way, it's going to come out to be the same thing. The natural log of 5 squared. So now I'll split this up again. So this is the natural log of 4 plus the natural log of 5 plus 2 times the natural log of 5. Well, I have the natural log of 5 plus 2 times the natural log of 5, which is actually going to be 3 times the natural log of 5. So my final answer would be the natural log of 4 plus 3 times the natural log of 5. And again, had I split this up different originally, then I should still end up with the same answer in the end. So I want you to rewrite the natural log of 5 halves in terms of the natural log of 4 and the natural log of 5. So pause the video, unpause when you're ready to check your work. Alright, so first I can separate this into the natural log of 5 minus the natural log of 2. Natural log of 5 is good, that's not going to change, but how do I get 2 to be a natural log of 4? Well, I know 2 is the square root of 4. So the natural log of 2 is the same as the natural log of the square root of 4. But square root of 4, because the square root would be an exponent of 1/2, I can bring that down in front. So this is the natural log of 5 minus 1/2 natural log of 4. Okay, so now I want you to do something similar, but we're going to do it with some generic log base b. So if you know log base b of 2 is 0.3562, log base b of 3 is 0.5646, and log base b of 5 is 0.8271, I want you to figure out what is the log base b of 30. I'll give you a hint. You're trying to come up, or split 30 up into factors of 2, 3, or 5. So pause the video, unpause when you're ready to check your work. Also, you're going to do log base b of 16 over 25. So pause the video and do both of those. Alright, so log base b of 30. First I split that up into log base b of 6 times 5. But 6 is 3 times 2. So I kind of skipped a step and I jumped and I split this up into log base b of 2 plus log base b of 3 plus log base b of 5, because 2 times 3 times 5 is 30. So log base b of 2 is 0.3562, log base b of 3 is 0.5646, log base b of 5 is 0.8271. Add them together and I get 1.7479. Log base b of 16 over 25 is log base b of 16 minus log base b of 25. 16 is 2 to the 4th. 25 is 5 squared. So this becomes log base b of 2 to the 4th minus log base b of 5 squared. Bring the exponent down in front. So this is 4 log base b of 2 minus 2 log base b of 5. Log base b of 2 is 0.3562. Log base b of 5 is 0.8271. Type this into my calculator and I get negative 0.2294. Alright, last few examples. So this is just practice. So I want you to rewrite and simplify each of these as much as possible. So pause the video, unpause when you're ready to check your work. Okay, so again, there's a few ways in which to go about this, at least for the first one. The second two, there's kind of one way to do it. But 243, I can split 243 up into 81 times 3. So I have log base 9 of 81 times 3. Well, that becomes log base 9 of 81 plus log base 9 of 3. Log base 9 of 81, remember that's saying 9 to what power equals 81? Well, 9 squared is 81, so this is 2. Log base 9 of 3, 9 to what power equals 3? Well, the square root of 9 is 3, so that's a power of 1/2. So log base 9 of 3 is 1/2. So this is actually 2 plus 1/2, or 5/2. The natural log of 8e cubed is the natural log of 8 plus the natural log of e cubed. The natural log of 8 is not a nice number, so I'm just going to leave it as the natural log of 8. But the natural log of e cubed is 3 because of my properties of logs. I can bring the 3 down in front, and the natural log of e is just 1. Same thing happens here on the last one. Natural log of e to the 5th over 7 is the natural log of e to the 5th minus the natural log of 7. Natural log of 7 is not a nice number, so I'm just going to leave it as the natural log of 7. But the natural log of e to the 5th is 5. So this is 5 minus the natural log of 7. Alright, so we want to make sure we understand our properties of logs, the change of base formula, the product property, the quotient property, and the power property. We will be using these properties when we are solving log equations.